Yes, class, am I audible to all of you?
Yes, Miss Yar.
Yes, ma'am.
Screen is also sharing. Just let me know once.
Yes.
Okay. Yes, class. So we had start. Rajita, how was your physics exam? It was supposed to be today, no? 8th.
Yes, ma'am.
So how was it, Rajita?
Ma'am, it was better than expected. The question paper was easier than last time, so it was all right.
Okay, then Rajita, do share your question paper with me on WhatsApp. All
Yes,
right.
ma'am. Yes, ma'am.
Fine, class. So we had started with prism. This was left. The last topic of ray optics. This is left is prism. So you have a case. What is a prism? Prism is not just a triangle that we see. Prism is what? Prism is a wedge-shaped orb. Means two triangular faces and three rectangular faces are kept like this. Then one like this. In this manner, it is constructed. So you have a condition which is known as angle of minimum deviation. That I wanted to discuss with you. Now see, we'll be just using this phase of triangle like this, because I told you in the last class also that on these faces only you have the refraction part occurring. And if on these faces only you are having the refraction part occurring, so why to draw the prism every time? Why to draw the back sides every time? So we'll be just focusing on these sides. All right. Next is C. In this, let's say this is the A part. This is the angle of prism, which I have mentioned, angle of prism. Now, in this prism, incident ray, light ray will be incident on it. So suppose I have drawn this. This is the incident. This is the incident. This is the normal to it. So what happens? First refraction will occur. In this, first refraction will occur. Because one medium was here, other medium is glass. So once you are changing the medium, when the light rays will be moving into, it will be refracted. This is the first normal. All right. So incident ray and normal, this becomes the angle of incidence. Again, at this surface, we'll be having one more normal, that is N2. And here the rays will be getting refracted. So what is this? This is the refracted ray. Between normal and the angle of refraction, we also use the term emergence. Emergence means angle of emergence. The surface from which the ray has been emerged out. All right. So this is R1, the refraction angle. This is R2. Okay. This is the emergent angle. These are the refracted angles. This is also one more angle that we'll be using in the derivation. Let's name this as X. Okay. If this is A, I'll name this as B. This part is as C, and this point it as D. All right. All these labels are made. Now see, if you look at this triangle BDC, can you notice R1 plus R2 plus this angle X? This is making an angle of 180 degrees, correct? So from here, R1 plus R2, this is equal to what? You have, this is 180 minus X from this equation, correct? This is R1, this is R2, and this is X. So R1 plus R2 will be 180 minus X. Now, if you look at this entire quadrilateral ABCD, this was in triangle BDC. if we talk about the entire quadrilateral ABCD. So here we'll be have, see, angle A plus angle X. Opposite angles of a quadrilateral, these make an angle of 180 degree. So we'll be having angle A plus X equal to 180 degree. Okay, so angle A is equal to 180 minus X. Can you see both of these equations are same? This is also equal to 180 minus X. The other equation is also equal to 180 minus X. If both the equations are equal to 180 minus X, it means you can equate both of these, right? R1 plus R2 you can equate to delta A, that is angle A. So this becomes R1 plus R2 is equal to angle A. All right, so this is the first equation that we'll get. First equation, not only in terms of derivation. This equation is not just in terms of derivation. This is a proper equation that is helpful for you further also. Okay. All right. Now, see, this is angle of incidence. This I have named, this is R1. Let me name this as, I am naming this angle which is being formed as angle 1, and this angle that has been formed as angle 2. Okay, this is acting as angle 1, this is acting as angle 2. Clear? Now which angle is this? Wait, let me draw it properly, otherwise it won't be clear. See, this is the triangle. If this light ray was not refracted, now we'll be able to see it clearly. Then I'll zoom in so that you will all already have an idea what we are studying. If this prism wasn't present, what would have happened? This ray of light would have passed straight like this. Correct? And how much emergence has been occurred? How much shift in the angle has been occurred? When we're talking about the angles, when we're talking about the rays, how much has been shifted? Can you see this bending of light ray has occurred? So if I produce this also backward, this is meeting it here. So what is basically happening? The original ray had to go like this. But because it is being deviated, it is going like this. So this angle that is formed, this angle is the angle of deviation. This is the angle of deviation, this entire angle that is formed. See, this is the angle of deviation that is formed. With this, the ray of light was going like this. This had to be the path of the light, but it is now going like this. So this entire gap of angle that is coming is the angle of deviation. Now the lines which I was mentioning you to mark were, this is actually angle 1. I am taking this as angle. This as angle 2. Now come back to this. Now you have understood the prism. The diagram is clear to you. Now we just have to perform the calculation part. See class, this entire angle of incidence and this entire angle, both are vertically opposite angles. Can you see? These lines are crossing each other. If you see this line and this line, they are crossing each other. It means this angle is equal to this angle. Similarly, this line is crossing this line. So this angle is equal to this angle. So what can I write? I can write angle 1 plus R1 is equal to angle of incidence. So from here, I know R1 is equal to I minus angle 1. Similarly, I can write angle 2 plus R2 is equal to E. From here, R2 is equal to E minus angle. Now what will I do? I have this, look, in this triangle again, let me. If you look at this triangle, angle 1 plus angle 2 is actually equal to delta, which was the angle of deviation that was occurring. Angle 1 plus angle 2 was the deviation that was occurring. Understood? Because the ray was moving like this. So if you look at the triangle, this is acting as the exterior angle. This is acting as the exterior angle. So now see, this is acting as the exterior triangle. So what can we say? If this is acting as the exterior triangle, what we can say? Yes, class. What is the equation that is formed whenever you have exterior angle? See, angle 1, this, please remember this property, exterior angle property. Angle 1 plus angle 2 is delta. So delta will now be equal to what? What is angle 1? We have to write down the values of angle 1 and angle 2. Okay. So from here, let's do one thing. From here, let's do one thing. Let's, instead of writing the values of R1 and R2, let's write the values of angle 1 and angle. So angle 1 is equal to I minus R1, angle 2 is equal to E minus R2. So delta is equal to I minus R1 plus E minus R2. Clear? So delta is equal to I plus E minus R1 plus R2. So from here, I plus E, and what is R1 plus R2? This is A. So this is the equation. All right, so this is angle of minimum deviation from the prism. Write it down, then we'll see the conditions for minimum deviation. Yes, some of you were telling that you haven't written this. I have scored. Now you can write. Okay, now the conditions for minimum deviation when we'll get the angle as less. So we have the equation delta is equal to I plus E minus A. So from here, if you have two conditions for angles to be minimum. All right, these are the value. For minimum deviation, basically two conditions are there that have to be fulfilled. First is that angle of incidence is equal to angle of emergence. Just a second. Okay, angle of incidence is equal to angle of emergence. In the second case, R1 is equal to R2. So instead of taking it as R1 and R2, we'll be taking it as R. So R1 plus R2 is equal to A. So 2 times R will be A. From here, we have the equation of R as A divided by 2. Now, if you apply Snell's law over here, sine I divided by sine R. So N is equal to sine I. Okay. We have to write down the value of I also. See, how will we get the value of I? Delta is equal to I plus E minus A. So from here, I and E angle of emergence both are same. So this will be 2I minus A. So 2I will be equal to delta plus A. From here, you have the value of angle of incidence as delta plus A divided by 2. So this is the angle of incidence. Now, when you will put it into Snell's law, refractive index is equal to sine I by sine R. What is the value of I? You have delta plus A divided by 2 divided by sine R. Sine I by sine R. What is the value of R? R also we have just derived. It is sine A by. All right. So this is your angle of minimum deviation conditions and this is the formula. We'll see questions. First, write it down from here. Okay, this question says calculate refractive index of material of an equilateral prism for which angle of minimum deviation is 60 degree. That is, you're having the value of delta given as 60 degree. Now, if it's an equilateral prism, what should be the angle of the prism? We just have the information that delta is 60 degree. Can you tell me anything about the angle of prism? Anyone? Very good, Shavi. 60 degrees. See, equilateral triangle, equilateral prism. It's just 3D form of it. So angle will also be 60 degree. Now, what is the value of n? N is sine delta plus a by 2 divided by sine a by 2. So n will be sine 60 plus 60 by 2 divided by sine 60 by 2. So this will be equal to 120 by 2, that is 60 degree. So sine 60 degree divided by sine 30 degree. So this is root 3 by 2. This is half. So refractive index will be root 3. Write it down. One more question we'll practice on the same. First, write down this question. Okay, this says that a ray of light passes through an equilateral prism such that angle of incidence is equal to angle of emergence. E is given as 3 by 4 times A. Now see, emergence is 3A by 4. Angle is 60 degree. So E will be 3 by 4 of 60 degree, which is 45 degree. Angle of incidence is 45 degree. Delta is equal to I plus E minus A. So this will be 45 plus 45 minus 60. So delta will be 90 minus 60, which is equal to 30. Now see, you have delta with you. Now N is equal to sine delta plus A by 2. Sine A by 2. This is the formula that we have. So N is equal to sine. Delta we have calculated as 30 degrees. A, since it's an equilateral triangle, equilateral prism rather. So we will be directly using the term 60 degree divided by 2. Then you have sine, again angle of prism 60 degree divided by 2. So this becomes, N is finally equal to, see, 60 plus 30, this is 90, 90 by 2 is 45. So this is sine 45 divided by sine 30 degrees. So this is 1 by root 2. And this is by 2. So this basically is ultimately root. Note it down. See, if the angle of the prism is very small, then we use certain approximation. This is as it is, what we've studied. We'll be talking about the refractive index. The refractive index here is 1. Refractive index of glass, I've taken it as N1. N1 is 1, N2 is N. So angle of deviation is I plus E minus R minus A. So see, if we apply Snell's law, this is 1 into sine I is equal to N into sine R. This is N into sine R. Fine. So when we have very small angle, we always write, see, sine theta becomes approximately equal to theta. So we can write this almost equal to I. So this becomes nr1. Similarly, here also when you will apply, this will be nr. So delta will finally be equal to nr1 plus nr2 minus a. You take n common, this will be r1 plus r2 minus a. What is R1 plus R2? R1 plus R2 is A minus A. So we take A common, we are left with N minus 1. Okay, why? Because R1 plus R2 is equal to A. This I just wanted to write. Write it down. Then we'll see, you have dispersion topic from this only, prism only. We'll start with that. See, you have Cauchy's formula. You just have to remember the formula. A, B, C, D, all these are constants. Here you have to remember that refractive index is inversely proportional to the wavelength. Red color has the highest wavelength. So if the wavelength of red is higher than wavelength of violet, this is the order. So refractive index of red will be less. And you know from the formula, delta is equal to n minus 1 into a. Delta is directly proportional to a. So whatever will happen, delta is directly proportional to a as well as it is directly proportional to n. So whatever will happen to n will happen to angle of deviation also. Also, n refractive index or wavelength, let me tell you. This formula, we'll do it in dual nature also. Frequency multiplied to wavelength is equal to the speed of light. Okay, so wavelength is directly proportional to speed of light. Speed of light or any speed. That's why whatever will happen to wavelength will occur to velocity. Clear? Now you have the next topic as angular dispersion. What is angular dispersion? See, if I tell you the refractive index or the delta, that is angle of minimum deviation, angle of deviation for red, and this is angle of deviation for violet. Angle of dispersion is the difference between them. That is delta V minus delta R. This is what is meant by angular dispersion. This is one thing to be remembered. Second, you have mean deviation. Mean deviation means average of these two. Delta R plus delta V divided by 2. So we usually say that the mean deviation gives us the yellow color. It's actually for the wide range for the yellow color. So you have dispersive power. Dispersive power is ratio of these two things. Angular dispersion by mean deviation. Angular dispersion by mean deviation. Like if I'll write the formula, we represent angular dispersive power by this. So angular dispersion, delta V minus delta R, right? And what was mean deviation? I told you it's the angle of deviation taken for usually yellow color. So write down the values for them. Ny minus 1 into A. Oh no, this will be violet. This is not yellow. This one is violet. So this is violet minus A into A minus. Then NR minus 1 into A divided by angle of deviation, that is for yellow, minus 1 into A. This is how we'll write. So see, from all of these, angle will be cancelled because you take A common from here. A is already here. A and A will be cancelled. So what we are left with? NV minus NR divided by NY minus 1. Remember, this is for violet, this is for red, and this is the refractive index of yellow. Dispersive medium and all I'll tell you, but write it down first from Cauchy's formula. Dispersion is there. It's a part of prism. Whichever details were there that I'm not discussing. The dispersion is what? Dispersion is basically splitting of the white light into its 7 colors. Means all the Vibgyor, you must have heard of Vibgyor. It starts from violet and ends with red. So when white light is incident on prism, all the 7 components get split up. This process is called dispersion, and the pattern of color that you obtain, that is known as spectrum. This is known as spectrum. Like this is known as spectrum. So you get these lines. Now the medium which allows dispersion to occur is known as dispersive medium, and which does not allow dispersion to occur is known as non-dispersive. So in dispersive medium, different colors travel with the same speed, or with different speed. That's why there is dispersion. But in non-dispersive, they travel in the same speed. Otherwise, see, white light is present everywhere. Why don't we see dispersion occurring every time, everywhere in front of our eyes? Because in air, dispersion doesn't occur. But whenever you have glass, you must have seen rainbow formation and all. This is all because of dispersion. Write down these 3 points as well. That completes with ray optics. In the next class will be on Sunday now. Saturday is off for you. Sunday we'll then start with atoms and nuclei most probably. I'll share notes, handwritten notes are there. So atoms and nuclei, you don't have to write much. Write down these 3 points first. All those who have completed, you can start leaving.